Okay, so yes, we were discussing this. We were done the last video, charging and discharging of a capacitor. We attach battery. There will be no current flow in open circuit. Whenever you attach capacitor with the battery, that battery is a DC source. Potential difference volt will be provided, and these two equations which we discussed in the last video. Yes, these were the equations which we even derived. So yes, let's get started. The small, it's written when a capacitor is connected to a source of battery, it gets charged. That's so simple. So yes, we were discussing this in the last video. So for suppose this is the 5, when 5 to 10% charge, you might have noticed that this charge like it start charging very fast, and gradually slowly it will become slowly, from 10 to 100, just because starting would be fast. Starting would be fast and then it become lower. Okay, and if your battery is going to be charged and you find, not find, but your battery or your phone got 63% charge, what this number tells now, when your phone gets 63% charge, this become time constant time constant. Okay, so we can just say time constant simply. How, what about 63% discussing? If your phone was 0, you plug or you start charging your phone from 0 to 63%. 0 to 63%, the time required is known as the time constant. Okay, so time constant is time required for a capacitor. Let me write this as well. Time required for a capacitor, to charge 63% of charge is called time constant. Okay, so I'm sure, and we can also write T, which is equal to R into C. What does this mean? R into C. R is the resistance, C here the capacitance. So time T here is the time constant, or we can also say time constant. The product of resistance and capacitance is known as time constant. So when a capacitor, this is all about uh, the charging. Now let's start with the discharging. What exactly is the process? Discharging. So what is that? You attach a capacitor with resistance. This is the resistance, this is the capacitor you attach. Okay, and here this is an open circuit. Well, here we have attached a battery. Okay, so we know that when a capacitor or the resistor, let me just write this first. This was done till the resistance and these all. You might have seen when a capacitor, when a resistance is attached, if you have just charged a phone, you got 100% charge your phone, and then when you're using your phone, you are getting discharging, and in starting that would be slow. Like in starting, slow charging would be used, slow, and then it will be initially it would be fast. Sorry, initially it would be fast. Your charging will not use very quickly, it will be like very fast, and then it becomes slow. Okay, then it will become slow. So we can say when a capacitor is connected to a resistor, this is resistor, and this is the capacitance, this is the battery volt, DC source, which is battery volt potential difference. Okay, so we can say when a capacitor is connected to a resistor, so C plus R. C here